Good morning, everyone. My name is Eleni Symeonaki. I am a member of the laboratory teaching staff of the Department of Industrial Design and Production Engineering of the University of West Attica in Greece, and I am here to present a preliminary approach regarding the trends and challenges about integrating Industry 4 technologies for smart energy management in the industrial sector. This is a preliminary approach because it's part of a PhD project of Mr. Kyrtsilas, who is not presenting. I am. Sorry. It's down. No. Okay, thanks. So, the scope of this work is to overview some significant Industry 4 technological trends that develop a path for the smart energy management systems towards energy sufficiency and sustainability, as well as identify some of the corresponding challenges regarding this issue. As we all know, energy safety is a major issue nowadays, mostly because of the current invasion of Russia to Ukraine, and additionally the rise in economic development during the past decades has led to an exponential demand in energy, which is expected to further increase in the near future. In this way, we think that adopting the cutting-edge technologies which advance in the context of the Industry 4, the industries are expected to be transformed into smart ones and will be capable of strengthening energy management. This is due to effectively measuring the power and predicting the demand, as well as regulating the distribution and consequently optimizing the grid. This approach is expected to enhance energy security with regard to sustainable policies. Sustainability is a major issue of nowadays. Regarding smart energy management in Industry 4, currently, there were some deficiencies in conventional power grids, as for example, inability to predict the demand, lack in efficiency in efficiently managing the energy distribution, and additionally delay in detection of failures. This has led to the advance of the smart grids. All SG actors, as we see here in this picture, are enabled by the I4 digital technologies, and they can control their energy needs, consumptions, and costs in real time. For having an effective energy management, we must follow some principles: energy supply availability, consistency and reliability, energy consumption regulation or reduction based on productivity, improvement of the equipment overall performance, decrease in the maintenance volume, service life extension and risk management for principal assets, and finally creation of economic and added value. For achieving smart energy, we use smart energy management systems. SEMs is a multi-level energy aware system. We see here the 4 levels, which by incorporating in this system IE4 technologies, we can integrate raw energy data into the corresponding industrial processes, perform energy effective and flexible production planning, improve the energy supply, and thus optimize the energy efficiency of the entire industry. There is a catch in the industry sector, whatever we do, we must not stop the production. The production must flow. So this is a catch. One of the most important I4 technologies is the Industrial Internet of Things, which differentiates a little from the traditional IoT. And a typical IoT infrastructure has also a layered architecture and consists of sensors, actuators, and edge-on nodes at the lower level, the physical level, IoT gateways and edge gateways. And then we have the IoT platform and on-premises server. This is the middle level. This is where we have also the middleware. And finally, at the upper level, we have all the analytics applications of raw data processing and automating processes databases. The demand for response mechanisms can automatically be regulated by connecting into smart devices so as to track occupants and energy usage and minimize respectively the operation throughout off-peak energy time period. For example, regarding the industrial sector, we can track the departments, the occupant department of each industry at any time and regulate energy at any period. The integration of the IoT into smart energy management allows the overall supervision and regulation of the smart grid with regard to actual energy and production costs, permitting the drawing of directions for further optimization. We have in this sector we have some challenges. The greatest challenge in industrial IoT, as in conventional IoT, is heterogeneity and data standards. So we need more reliable communication protocols for monitoring and performance evaluation. Another major issue is privacy and security. I think the colleague presenting the paper before mine mentioned some interesting things about security in the smart grid. We have to face the fact that the IoT infrastructure may be breached and be submitted to substantial damage. Another technology of the I4 industry is big data analytics. A smart grid can function smartly and effectively, but this is due to data analytics. So there are five types of analytics that can be used regarding smart grid, and this is signal analytics focusing on signal processing, event analytics focusing on occurring events, state analytics focusing on the visualization of the smart grid status, engineering operation analytics assuring the smooth functional operation of the smart grid, and finally consumption analytics providing insight on the energy consumption. There are also several challenges in this issue. This is the identification of unexpected correlation or hidden consumption market trends. This is a trick, and some other usable information for larger and more complicated data sets. Additionally, the way of reliably storing and retrieving this vast data with regard to the priority of applications, and finally, the dependability and safety of intelligent decision making. Blockchain, the third technology of the Industry 4, we think it would matter in energy management. Integrating blockchain with the smart grid demonstrates its effectiveness in addressing concerns regarding security and privacy. And there are also some reward models and disciplinary systems, as well as standardization. So, blockchain may be used to create more transparent and secure energy systems that benefit both consumers and producers. The integration of the blockchain technology in the smart grid is still a hot research area. It's very, there aren't many papers, many research works regarding this issue. And although the blockchain is already being used in industry to organize diversified supplies of renewable energy without the involvement of intermediaries, there are several challenges that need to be addressed there too. An example of this are rewards and regarding photovoltaic panels, etc. So this is an indicative system for the smart grid blockchain. Okay, the data owners upload their data. The data server publishes the task, and the data miners check the transaction quality and data quality. The right rewards will be given based on the data that users upload. And finally, the fourth technology, the fourth I4 technology we think it would matter, is artificial intelligence and machine learning. Of course, there are two different technologies, but they correlate as well as deep learning. There are approaches for incentive-based demand response models. There are also approaches for utilizing deep learning. Deep learning is in big association with big data, of course, and analytics, to build a real-time incentive mechanism for the smart grid. In this way, service companies can buy energy from their clients and provide meritorious client incentives. And reinforcement learning was used to determine the best prices while taking incentives into account, while neural networks were utilized to predict energy usage prices. And finally, various incentive mechanisms that can be used for smart energy systems. What is the conclusion of this preliminary work, this preliminary approach we studied from the literature? Since the industrial sector is accountable for a sizable portion of the total energy consumption, efficient energy management in industries, of course, is of supreme importance. In this regard, we think that the Industry 4 approach, along with cutting-edge technologies, which advanced in its context, are expected to transform existing industries into smart ones, being capable of managing energy consumption in more efficient and sustainable ways. As future work, because as I said, this is a preliminary approach, we plan to provide more particular recommendations for suitable strategies depending on specific system characteristics and influencing parameters, and additionally embody the various characteristics of this overview technological trends for efficient management training, and examine the economic and environmental consequences of presenting flexibility strategies. Our main scope as future work is to combine these technologies we mentioned before and provide a system that is very ambitious, of course, that would help in energy management, in the industrial sector especially. In this point, we would like to acknowledge the postgraduate program which financed this presentation. And thank you for attending. Any questions? Thank you very much.
Thank you. Thank you once again. We give a